When you visualize England, what images come to mind? Perhaps it's stately ivy-covered country houses or medieval cathedrals. Maybe it's crenellated castles on green hills. What you probably don't think of is a building like this. This spaceship-like structure and the synchrotron that it houses represents the largest investment ever made by the British government in scientific research. We're going to go inside and learn about the activities that occur here from one of the resident scientists, Dr. Isabel Moraes.
So we are inside the synchrotron building now, and just here what you can see on this yellow color actually is the beam lines, where inside the beam comes from the storage ring inside these beam lines, and where the experiments they take place. A synchrotron is a facility where electrons are accelerated at the speed of light or near to the speed of light and generate X-rays. Then these X-rays will be used by different beam lines to different applications, in our case for biology and biochemistry. The Membrane Protein Laboratory is a very unique laboratory. It's a totally dedicated lab to the study of membrane proteins inside the synchrotron building. So this makes the lab very unique. It's the only laboratory in the world inside a synchrotron. 20–25% of our genome, of the human genome, codes membrane proteins. In nowadays, 60% of the medicines we have available in the market, they target membrane proteins. So studying membrane proteins is very important in terms of drug target, because many of these medicines, they have been developed without knowing the membrane protein structures, the targets that they have been designed for. So they have a huge number of side effects. So if we can solve and understand the structure of a particular membrane protein and how the drugs they interact with this particular protein, we will understand much better the way the medicine operates and function, and the medicinal chemists can actually develop better drugs which are more specific to this molecule, and once you take the medicine, they are not spreading into your body and binding many other proteins that are not related actually to the disease or to the specificity of the medicine. Membrane protein is a very important class of proteins because they are embedded in the membrane. Our bodies, they have cells. The cells, they have membranes, and these proteins are attached to the cells' membranes. They are very important. They act like gates or like what we call signal transducers. They are very much associated with many diseases: Parkinson, dementia, Alzheimer's, and cancer. Protein crystals, membrane protein crystals, are very difficult to obtain, and when they grow, they are very, very, very tiny. And we need to screen large amount of crystals. To do this, the best way is to have the lab located inside a synchrotron facility. So this way we have direct access to the synchrotron beam lines, direct access to the beamline scientists, and working together with them, we can have a better approach to these difficulties that we have with this type of crystals. These beam lines, they provide us with X-ray beams 10 million times brighter than the sun. So in a sense, they operate like a microscope. They are the ones who provide the light, and this light will allow us to see the protein structures at atomic level. So this bright light will shine on the crystal. The electrons will be scattered by the atoms, and based on this we can visualize the protein structure at atomic level.
We all know where amazing facilities like the Diamond Light Source come from. brilliant engineers, ingenious scientists, and a society that's willing to invest in this kind of magnificent endeavor. But what about the scientists who work in a place like this? We're going to talk with Dr. Moraes about where she came from.
When I was born, I was 3 weeks overdue, and this has created epilepsy. I started having epileptic fits immediately when I was a baby. Then they stopped for a period of years, although the epilepsy carried on, but the epileptic fits stopped. And I think when I was about 5 years old, everything started again. When I reached secondary school, the medicine was really interfere with my academic studies. Because my epilepsy was really catching up from 11 years old until 13, it was really creating huge problems in the school. I was not able to catch up with my colleagues. I was really behind, and in Portugal, education is like, if you don't have certain grades on the subjects, you don't move year. So they ask you to repeat the year. And then when I reached year 8, it happened the same thing. They said I could not move in year 9 to year 9 because my performance, my academic performance was not that great. The science modules were fine, but during secondary school you don't just learn science, and they were very concerned. So my parents, they took me back to the doctors, and they told them that with the medicines and the way I was, it would be very difficult for me to achieve higher academic expectations. At some point I started going into these hospital appointments, and I used to see these children very sick, and I said, I'm not as sick as these people, and this is really interfering with my studies. I don't think I need these pills. So I started thinking a way of trying to find a way where I could not take them, and asking to my parents or to my grandma was nothing they will be convinced. The doctor said I would need to take them until the end of my life. And we had the dog, right? And she used to stay near to us, very happy during meal times. And I said, okay, you are always waiting for something from the table. Here it is, my very nice epilepsy pill from the table. And it's orange and it's tastes nice, the sugar coating of the pill tastes nice. So when I tried the first time, she was a very happy dog to have it, and I was very happy to give it to her. So my grandma used to clean the area where the dog sleeps. The dog was having the pill, chew or just have the sugar coating, and then when reached to the medicine bit that's not so tasty, the dog was splitting them up into the corner where she had the blankets. And my grandma went clean the area and saw a lot of pills. I just heard my name being called. I was told off by parents and grandma, I was told off by the doctor and so on. And here it comes the news. I used to do a electroencephalogram every 6 months. And when I did this time, came surprise, surprise. The doctor said, Isabel doesn't have the same spectrum as before. The traces are totally different. This is just a normal brain encephalogram. There is nothing that we see here. So we can't explain, but probably she doesn't need the pills anymore. Until today, I'm really clean, and in terms of there is no signs of epilepsy at all. Of course, this had a huge impact in my life because I was not feeling sleepy anymore. My academic performance in school, I was myself. Since I was very, very young, everything that was related to science, I always love it. And I think my father had a very important role on it because he loved science as well. My father was, by profession, he was a dentist technician, and he had a small workshop at home. And I love to see him working on that, and I love to see him mixing liquids. In Portugal, the kitchen floor is always marble, and the worktop is marble. And one of the things I would love to do it was on the top of the kitchen, worktop kitchen, slice the lemon and do it like that, like prints. When you squeeze the lemon, the juice, which is acid, eats the marble. So the marble goes from this pinkish color into a white color. And of course, my mom used to be furious with that, or just squeeze a few drops on the kitchen floor. And they immediately knew that was me, that I was trying to do some chemistry experiments on the kitchen floor. The stains comes out after a while, but they stay for a good 3 weeks. So when I was in primary school, one day I took a book from a neighbor about chemistry, and the teacher was so crossed. The chemistry is not for your level yet. So I always loved science. My grandma was not displeased, but when I said I'm going to study chemical engineer as a first degree, she looked at me and said, I'm so disappointed because this is for men. This is a profession for men, not for ladies. And I laughed when she said that. I managed to have grades enough to attend a university in Lisbon because the entrance requirements are a little bit more higher. And I have not done just chemical engineer. I did what is called industrial chemical engineer, so the degree would be a little bit more pushed in terms of practicals. My father was not a Christian. In his opinion, scientists and God at that time would not correlate or coexist. To have someone that would say, I'm going to church once a week, I believe in God, and I believe God has created us, that would make a big problem for his convictions. My mom is a Christian, but she never attended any church. She was busy working. And for her, if I would believe it or not, she would not mind. My father was the one who used to push during that period. It was a bit complicated. He didn't like to have what he used to say, Christians in my house. I had a very strong influence from my grandma, who was a very strong Christian lady, and she strongly believed God exists and God has creating us. And when I started studying, I remember on the secondary school, they gave me a biology book and had all this evolution, had started with the monkey and finished with the man. She always told me, this is what some scientists believe, but is not what it's written in the Bible. Problem started when you reach the 15 years old and you are already a teen and you need to start producing your own opinions, and you needed to make a decision. Can I live my life as a scientist or as a person who loves science and at the same time keep my Christian background or my Christian principles? I had teachers saying evolution is correct. They believed in God, but they used to say, Isabel, I believe in God, but not a magic God. And once I remember I told the teacher, but if God is not magic, he's not God, it's just a minor God. And she was furious because I said that in front of the class. But the time moves on and you mature a bit more your answers, and you try as well to understand the reason why people believe in evolution as well, and listen their sides. And of course I start creating my own opinion as well. After I finished my first degree, I moved to London because my boyfriend was living here, which is my husband today. I did my first degree in chemical engineer, but was missing the biology. I like biochemistry as well a lot. And so I enrolled myself, and 2 years later, I finished the master's degree in bioinformatics. And and molecular modeling. So during the masters I learned quite a lot of biochemistry, which I didn't have it on my first degree. And then of course I moved into a PhD in biochemistry, that was X-ray crystallography for macromolecules. That means crystallography of proteins. During my PhD I was more and more convinced, right, that we have been created by a very intelligent being.
Dr. Moraes was not compelled by her parents to believe in some religious idea about a creator God, and certainly her education was not designed to indoctrinate her into some kind of belief system along those lines. And yet, during the course of her science education, she learned things that drew her in the direction of believing that there is a creator God. But what is it about the science that she does on a day-to-day basis, the protein chemistry that she studies, that continues to point her in the direction of a creator God?
When I'm in the lab to extract, if I'm working in a protein that is related to, for example, a brain function or a function in our brain, if I extract and I purify that protein by itself, it's a nightmare because the protein is not stable by itself. You need so many things to keep it stable in your body. And outside the body, as a single thing, they don't work. So if you think as a bacteria is a very simple organism, but even simple, everything works in a certain coordination. It's harmony. Everything works in harmony. You cannot detach parts. The cells in our body, if something goes wrong with the cell, it's programmed to terminate it. So we call it apoptosis. So when someone develops cancer, it's because something went very wrong. Because our cells are programmed since the beginning to, if something goes wrong, to really terminate the program of the cells. And cancer basically is when this has failed. And remove one protein, or we don't need even to talk to proteins. If you remove some nutrients, calcium, magnesium, even tiny nutrients, ions from our bodies, we start not functioning well. And this just, to me, proves we were designed and we were made and we start existing since the beginning like we are. The way I see biochemistry, the way I look at biochemistry in the lab, more and more I'm convinced we are like this since day one and not by parts. It would not work. The way we are made, the protein structures, the way all these biomolecules interact with each other, it's almost impossible to say we have not been created. Proteins, they all exist in complexes interacting with other proteins. So if one protein is not properly folded, not only affects its own function, but affects the function of the neighboring proteins and the neighboring proteins to another, and this cascades into the cell, and of course your cell will not operate anymore as supposed, and from the cell goes into tissues and organs. You see, it's something that can cascade very rapidly into a higher organ level and lead to failure, you know, body failure. One protein misfolded can lead to many disastrous consequences. 50 years ago and 60 years ago, we used to study these things as individuals, like elements. But biochemistry is not about individual biomolecules, it's about how these biomolecules interact with each other. And if part is missing or a little tiny thing is not functioning properly, as I said, everything can go wrong. We cannot have half of us functioning well and while the other still evolving, right? And if you say, oh, but evolution was progressed and everything, even though the mutation rate in our cells is very, very low to avoid disasters. So how could we as well just have the right mutations on the right direction? I see this in the lab because sometimes when I mutate my proteins, it's empirical. I don't know what's going to happen. I need to produce many mutants and see which one probably goes in the right direction. So in a sense, I'm playing evolution, and usually it doesn't work. I see how the sequences, they were very well designed, and how two proteins very, very similar, just with a couple of residues different, right, can have so different folding and so different function. So to me, when I'm really absorbed in the lab or thinking about this, is when I see God. I see how God has created things, and that protein works well, but together with that, it works even better. And the proteins, they work as a team. And when people like me, a structural biologist, have opportunity to look into these things at atomic level, so what I see is the atoms, how the atoms are interacting and connecting to each other and interacting with each other, is amazing. I don't see how evolution can have happened. I just see God's work.
One of the things that fascinates me about Dr. Moraes is that there is a theory out there that says the more we know about science, the less important God is. And yet in the case of Dr. Moraes, we see exactly the opposite. On the one hand, she knows about what's going on with the atoms that make up the molecules from which life is comprised. And yet on the other hand, she sees in this evidence for some kind of creator. I wonder how many other scientists are thinking along similar lines.